All right, so next we're going to talk a couple about transition criteria. An easy way to think about the transition criteria is to actually go back to a basic V life cycle model. And this is kind of related, this is kind of another way of writing down the software portion of the D178C life cycle model. But transition criteria are really kind of interface point between the various D178C processes. You need to kind of determine when you're ready to go, for example, from a set of high-level requirements. When you think you're done enough that you can go from a set of high-level requirements to the low-level requirements. Yeah? When the low-level requirements are done enough so you can actually go to your architecture and module design, and finally your coding. So you need to determine each one of these transitions, and you need to define when it is that you can actually do this transition. Yeah. So what you have to make sure is that these transition criteria are quantifiable, flexible, and that you document them. If they're flexible, it's really nice because now you can actually run a particular process in parallel as much as possible. For example, you don't need to necessarily finish all the high-level requirements to start working on low-level requirements. Yeah? So what you need to do is you need to specify specifically when you can do what. So these are really, when can you go from one life cycle process phase to the next one? And this doesn't necessarily mean that you have to be complete with all the high-level requirements. You can say, I'm going to just finish some of them and then start already going to a higher detail. But you need to document this transition. Yeah. Of course, you need to make sure that everybody agrees. You transition from one process to the next, and both the process owners, the people that are in charge of these processes, must agree to that, and you must present that for every process, of course. I put the software approval timeline here. Really, we've talked about this already when we start talking about the certification process. This just gives you kind of a timeline for the software specific aspects as defined in the software liaison section of the document. Okay, so far we've also talked about software lifecycle data, and think about that as all the data you produce during the software lifecycle. In other words, that may be including the plans that you've written down, the explanations, records of code changes you made, records of requirements you made, the requirements documents themselves, the evidence of particular verification activities like tests or reviews. So what you see is that this is really all the evidence that you need to deliver so that the certification authorities can look at the data and check out how good of a job you've done. So make sure that this data is unambiguous, complete, verifiable, consistent, modifiable, traceable. In other words, all the ingredients that we said were good attributes for requirements. Now, one of the things that you need to do is that the software data is very important for aircraft certification. Now, if you see that in the end, when before you get software approval, remember, you cannot certify software. You certify a product. Software just gets approved by the certification authorities. So the document that forms the basis for the software approval is referred to as the software accomplishment summary. And this document tells certification authorities what you did during your software life cycle, and it relates directly to your basic initial plan, which is called the plan for software aspects of certification. So this PSEC is very important because that is your master plan. This describes how you're going to create your software product, and that's where you're going to say that your process generates a software product that's worthy of an approval by the certification authorities. Then the certification authorities use this plan and check out if your proposed lifecycle processes are sufficient. If you look at a typical PSEC, you'll include things like an overview of the system, an overview of the software, certification considerations, what kind of life cycle data you're going to generate. Of course, you're going to describe life cycle, the data itself, what your schedule is going to be, and some additional considerations, which I will talk about a little bit more detail. So if you look at your system overview, you're really going to describe the system function. The software is part of the system, along with the hardware. So you need to describe what this software function is. And also what we're going to say is this function in how far that's allocated to hardware and software components. So in this case, you also need to identify, okay, what's the system architecture, what processors do you use, how you interface between the hardware components and software components, and what kind of safety features at the subsystem level have you envisioned for this particular system. Yeah. So if you look at the software overview, in the software overview, you're going to just you're going to describe what kind of safety precautions or software safety and partitioning concepts you're going to use in particular. Things like multiple version dissimilar software, redundancy, fault tolerance, timing and scheduling strategies. These are all things that you need to describe in your software overview section of your PSEC. And remember, by fault tolerance, we've talked about this definition a couple times before. We really mean it's the ability of a system to continue satisfactory operation in the presence of one or more non-simultaneous hardware or software faults. And one way to do this is to exploit redundancy. And there's ways you can do things like similar redundancy. There's the components that you have are identical copies, or at least similar. That means if one fails, at least you have to back up one. Or they're dissimilar. That means they're redundant components. They do the same, but they've been independently developed. Of course, what's the example of the dissimilar redundancy is that you may have less probability that you're going to have a common mode error due to a particular choice in software language or design approach, or actually even team members. So as I said before, you can have multiple versions. So one of the things that you see that you have to kind of describe in this PSEC is what kind of safety concept you use. So one thing would be the multiple version dissimilar software. In this case, you have 2 or more versions of the functions specified in the requirements and their development independently. And then you can still define how you're going to execute them. Are you execute them in serial or in parallel? And of course, you have to specify how you're going to guarantee the independence. There's some exception handlers on the other end of the spectrum, and we'll talk about that later when we start talking about coding. And then recovery blocks, in which case you have 2 or more versions of the function, but you're going to only execute one of them, and then when you find out that which is referred to as the primary, and then when you find out the primary is not working, you're going to then start the execution of the secondary, which is kind of similar to a standby system when we talked about system safety assessment. Now, so these if you look at N version dissimilar software, that's an example of what we refer to as forward recovery mechanisms. You enable the program to repair a corrupted state because you have backup running, but you also have backward recovery mechanisms. And that's the example is recovery blocks. You have your primary fails, you're going to start up your backup, your secondary, and then you kind of roll it back in time to the point at which there was no problem. Now, another thing that you'll see in the PSEC that you have to address is partitioning. And partitioning means that you provide isolation between functionally independent software components. Especially in modern aviation, you may run multiple functions, at least you may run the software for multiple functions on one hardware platform. If you want to do is you don't want to have any coupling between these individual software components, so you have to kind of isolate them from one another. For example, here you see there's 4 software components running, and you want to isolate. You want to have them on separate partitions. You don't want to have any errors. For example, in this level D component, to cause problems for this level A component software. So what you need to do is you need to separate the hardware resources. You need to check out there is no control coupling between these and no data coupling. In other words, you want to be careful with shared memory and overlaying memory. Things like overflowing arrays in level D code. If they cause you to override memory that was used for level A, that would not be a good idea. So actually there is the standard ee6083 which talks exactly about this partitioning concept. And of course you can buy real-time operating systems now that are D178C ready and also ee6083 compliant. In other words, they support a partitioning strategy as shown on this slide. If you look at the certification configuration section, really in the PSEC, what you have to do there is you want to make sure that you give a summary of the certification basis that you had established during your certification processes. You want to make sure that you have identify the software levels that you propose, and of course you have to justify these software levels by making the correct reference to the system safety assessment processes, or the things like the preliminary system safety assessment and the functional hazard assessment. And of course you have to describe the software life cycle that you're going to be using. And of course, this is highly dependent on the software standard that you're going to use, like D178C. And of course you're also going to have to mention and identify the software lifecycle data that you'll be producing. And you want to make sure that you're going to explain the relationship of the data to each other. Finally, a schedule. And as part of the schedule, you may want to check out when you're going to do some reviews. And by reviews, I don't mean software reviews or verification activities. I mean major reviews that you see as part of your life cycle. But you also want to show where the transition criteria are here. Now there's a variety of the other additional considerations, things like tool qualification, making use of previously developed software by the same company, or making use of commercial off-the-shelf COTS software, field loadable software. There's a variety of things there that are actually pretty well described and addressed in the textbook. So I would definitely look in the textbook and find some of these sections. Now, common PSEC problems are that the additional considerations section is not sufficiently supported. In other words, you not sufficiently address some of the things that should be addressed in the additional consideration section. For example, if you have COTS software, there's not enough there just to show that, okay, you use COTS software, and what are you going to do to deal with COTS software? Yeah. Also, often, either the system or software descriptions are either too detailed or not detailed enough. You need to kind of have the right amount of detail there. And of course, safety claims, in other words, what's my criticality level of this software? My assurance level of the software? You need to really substantiate that claim with the necessary references to the functional hazard assessment or the preliminary system safety assessment. Now, on the other hand, as said, for software approval, we mainly look at the software accomplishment summary. The software accomplishment, whereas the PSEC is at the beginning of the software lifecycle, the SAS is towards the end of the software lifecycle. And as a result, it includes a whole lot of the same sections that you had in the PSEC. Because what you want to do is, in a summary, you want to say, I promised certain activities and things in my plan. In the SAS, you're going to say, this is how I did it. Of course, in addition to the sections that are indicated in black, which were also in the PSEC, there's a couple of other sections like the software characteristics, identification, change history, software status, and the compliance statement. Now, change history, this is nothing related to what you do in configuration management, that you keep track of all the changes in your code. Yeah? This really means, by change history, means that this product that you're now developing is a change to an already existing product. In other words, you already had a product that was approved, but now you want to change this product. So and you want to make changes to this project, and this plan is for this new project. So in your says, you're going to identify, okay, what did you do? What change did you do to the already improved product? So for a new product, there wouldn't be anything. Of course, you know, these changes may be safety related, life cycle process related, whatever. By software characteristics, you know, since this happens at the end of your complete software lifecycle process, at this time you know that the code size is executable, you know some of the timing and memory margins, you know how many resources you need for this software component, and you actually have ways to measure these characteristics. So in the software characteristics section, this is what you're going to be managing. Software identification and status. So you're going to just identify for the latest version, you know, every configurated item you're going to uniquely identify, and you're going to say what is the status of this. In some cases, you have this called minor problem reports. And we'll talk about these in a lot more detail. But some things may not necessarily be completely done yet at the time of certification. So you need to identify that in this software status section. Yeah. And as I said here, the problem reports a document describe the presence of a problem that still must be resolved. But most of these problem reports are related to problems that are not necessarily safety related, and you kind of need to convince the certification authorities that that's the case. And these must be minor problems, not major problems. Now finally, included is of course the compliance statement, which is actually a statement of compliance, you know, kind of an official thing, which you say that everything that you've done in the documents is in compliance with what you promised in the plans. And finally, the software configuration index. You know, here we really, you know, it tells you, okay, what configuration we're in. So we may have different version numbers for all of the lifecycle products. So this includes the software product itself, the executable, every source code module, any form of previously defined software. We need to identify, okay, what is the current configuration of this? And here you see a little bit more detailed layout.